Now, if it does all go well, Super Heavy will fire up its 33 Raptor engines and it'll lift off from the launch pad down in South Texas. About 3 minutes into the flight, we're going to hope to see the Super Heavy separate from the Starship spacecraft. It'll then perform a flip maneuver. So there's that. You can see that on your screen. And then it'll boost back in order to make a hard landing in the Gulf of Mexico.
And while that's happening, we hope to see Starship's 6 second stage engines ignite and watch as Starship coasts for about an hour at altitudes ranging between 150 and 250 kilometers before re-entering Earth's atmosphere and make its own hard landing in the Pacific Ocean about 250-ish kilometers offshore.
Now, we are getting great camera views right now, but that's because we are on the launch pad, so we've got umbilicals and connections straight to the vehicle. But we aren't expecting to get very many good views once we get past booster separation.
Yeah, we do promise, though, for any views that we do get, we will share them in real time. We are watching live with you all, so we're excited to see those views ourselves as well.
Now, in a little bit, we are going to take a closer look at the vehicle and the launch pad. But first, today is a super exciting day. Everyone on the teams across Starship have been preparing, doing a number of tests and dress rehearsals for today's launch attempt.
Yeah, that's exactly right. In fact, we saw a nice little recap of those tests in the intro video to today's webcast. For those of you that are following along, you know that many of those tests ended in those rapid unscheduled disassemblies, or RUDs as we like to call them. And it's been a long road to today. Just in 2022 alone, we had 9 static fires. We've had a couple of wet dress rehearsals. And of course, the launch control team has done numerous simulations as well.
So major shout out to the teams that have been preparing for today's full up integrated test. In fact, we've got a shot of Star Command, the South Texas launch control team. Look at all the people ready for today's launch attempt.
Yeah, that right there is our South Texas Launch Control Center. That is basically ground zero for everything that is happening today, in addition to a couple other control rooms that we have operating as well with operators on console, including the Mission Control Center here behind us here in Hawthorne, California. But with that being said, our very own Zachary Lupin is one of our SpaceX employees at our watch event in South Padre Island. Hey, Zach, how are things going on the ground?
It is a great day for a test launch today, Kate. Hello, everyone. My name is Zachary Lupin, and I'm an avionics reliability engineer here at SpaceX, and I'm at the Cameron County Amphitheater, where a growing number of SpaceX employees are gathering to watch what we hope is the first liftoff of a fully integrated Starship. Now, the Starship team has worked incredibly hard for today's launch test. Over the past weekend, teams held a launch readiness review, which included a comprehensive review of all of our vehicle systems, looking at avionics, GNC, communications, software, structures, as well as our Raptor engines and propulsion in general. Now, we are only about 5 miles away from the launch pad, so it's a pretty good view for today. And as we get into as we start to approach T-0, everyone here is clearly very excited for the events that are happening today. So as we get closer to T-0, I'm going to throw it back to Hawthorne to talk more about our rocket.
Awesome. Thanks so much, Zach. And we've actually got a little bit of a crowd forming behind us, too. Now, we've got a shot of Starship on the screen. The entire Starship structure you see is made of stainless steel. And when that's fully stacked, it stands about 120 meters tall and about 9 meters around. To help you give a sense of just how big that is, we've captured a video of some of our teams doing final integration prep work in advance of today's test flight.
Just like Falcon 9, Starship has 2 stages, which we will talk a little bit more about in a minute. But in addition to those 2 stages, Starship actually has a 3rd stage called Stage 0. It consists of all the launch pad infrastructure built around the rocket. You can see a great view of it there on your screen. It's truly an engineering feat in its own right.
And I feel like it's something we don't talk about very often. There's a lot of infrastructure that goes into fueling and preparing the launch vehicle before a large test like this, really any launch. Now, let's talk about Super Heavy. The name says it all. It's super, it's heavy, it's super heavy. It goes by some other names, the first stage or the booster, but whatever you call it, the Super Heavy will be the vehicle responsible for powering Starship against that mighty gravitational pull we've got here on Earth. And when it's fully operational, it's going to get Starship to orbit.
The booster alone stands about 70 meters tall and is about the same height as a fully integrated Falcon 9, but with a diameter roughly 2.5 times that of Falcon 9 and with 33 much larger engines.
Yeah, and having those engines, and oh my gosh, I love this shot. We can see looking up into the launch mount at the 33 engines on the booster. Those are each of the Raptor engines that's going to power today's launch attempt.
Yeah, this is an incredible view. One of my favorite views that we're going to get today. We don't have this kind of view on our Falcon 9 launches, so this is so exciting to see. You can even make out the paint markers indicating which engine is which. Like we said, there are 33 of them. So there's a lot of fire that's going to be coming out from those engines in just over 31 minutes from now. As we mentioned before, there are 33 of them on the Super Heavy, the booster, and we don't see it right now, but the cluster in the center are the ones that are actually going to gimbal and help steer the booster back down for its water landing in the Gulf.
Yeah, and they're a little bit different, Kate, than our Falcon engines. So on Falcon, we use a gas generator cycle. Here's a fantastic shot, actually, at the inner stage, so we can see the 6 engines that are on the ship side, 3 gimbaling in the middle, and then the vacuum engines, you can see 2 of them, and the other ones on the other side of the cluster in the middle here. So Raptor's a little bit different. It uses something called stage combustion, which means we basically pre-burn both the fuel side and the ox side, and then get those up to the right temperatures and pressures, and then mix them in the combustion chamber. It allows us to get higher thrust and higher efficiency on these engines than on Falcon 9. Now, Super Heavy also has 4 grid fins to assist with orienting itself during the return back to Earth, as today is the fully integrated flight test, and the first one, we're focusing on safely testing just the fundamental systems and operations on the vehicle. So what that means is we won't be attempting to land on land today. Instead, Super Heavy is going to be making that hard water landing in the Gulf.
Starship, or the spacecraft, is the second stage and makes up the top portion of the vehicle. It's designed for carrying passengers and cargo between destinations on Earth, Earth orbit, and planetary destinations. It stands 50 meters tall, a little taller than the Statue of Liberty. It's comprised of 6 Raptors. We saw those just moments ago. 3 of them are optimized for sea level, and the other 3 are vacuum engines, and they're optimized to operate in the vacuum of space. They provide a maximum of 258,000 tons of thrust in vacuum. The spacecraft is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable precise landing at the intended location. You can see a view of those flaps there.
Now you can see the entire stack is vertical, and that's because Starship is designed for vertical takeoff and landing, as opposed to taking off and landing like an airplane. And that's really important because we don't have runways on the Moon and Mars. Fortunately, gravity at both of those destinations is not nearly as high as it is here on Earth. On Mars, it's about a third of what Earth's gravity is, and on the Moon, the gravity is just a sixth of what it is here. So Starship can take off in both of those cases without needing the Super Heavy booster like we need here on Earth.